Hi everyone, welcome to the Department of Energy's Savannah River site. We're going to go on a virtual tour today and show you a lot of things that go on behind the scenes here at our site. So come on, let's get on the bus. The Savannah River site is a key United States Department of Energy industrial complex responsible for environmental stewardship, environmental cleanup, waste management, disposition of nuclear materials, and maintaining our nation's nuclear deterrent. For 70 years, Savannah River site has been dedicated to maintaining the highest possible safety and security standards, protecting our worker, the public, the environment, and national security interests. Our driver today is Mr. Tim Schultz, and he and I are proud to show you Savannah River site. Okay, so one of the first buildings that we come to as we come into A area or Alpha area would be the Savannah River Ecology Laboratory. This is their main complex here on site, but they do a lot of wonderful things all across the site. It was first established in 1951 when the Atomic Energy Commission, now the Department of Energy, asked several universities in the area to come out and do a one-time baseline study on all the plants and animals here on the site. Dr. Eugene Odom from the University of Georgia asked the Atomic Energy Commission if he could do a further study into the effects of not only the construction but the operations that would go on here. You know, this site was mainly farmland before, and now he wanted to see what the effects of industrialization would do to the plants and animals. So he got a grant from the Atomic Energy Commission of $10,000. Well, that was a pretty good little amount in 1951. It wasn't enough to fully fund his program. So he came up with the great idea of using undergrads, interns, and graduate students to help him do his research. And then in 1954, it became a permanent fixture here on the site and has been here for 70 years now, doing great research. As a matter of fact, modern ecology as we know it today was born right here at Savannah River site through the wonderful vision that Dr. Odom had. Okay, so on the right side out the bus here, you can see the main campus of the Savannah River National Laboratory. So Savannah River National Laboratory is one of 17 of the Department of Energy laboratories. They're the newest in the complex of about 17 years, but they've been on site since day one in the early 1950s. They've helped develop every process that's gone on here at Savannah River site, from handling the waste to dealing with the tritium supply, and helping to maintain all of these processes that we do here. They're mostly in the Environmental Management Lab of the Department of Energy complex. There's approximately 1,000 employees throughout the whole site. Most of them are here at the complex in A area. We have about 200 PhDs, a lot of them internationally known for their work. The Savannah River National Laboratory is very important to not just Savannah River site, but to the nation and also internationally. Just one example is helping the Japan Atomic Energy Agency after the Fukushima nuclear disaster. And not only that, they have several other missions. They work with different government agencies as well, such as Homeland Security, the FBI. We have a forensics laboratory funded by the FBI and SRNL to deal with any kind of radiological exposure out in the real world. They can reconstruct a radiological crime scene right here and have done it in the past. When we say the phrase, we make the world safer, Savannah River National Laboratory has a large part in doing that. So as we make our way on out into the site now, we'll talk a little bit about the size and the area where we're located, etc. We're about 15 miles south of Aiken, South Carolina, and we're about 310 square miles. To put it into perspective, The beltway around DC would fit inside of Savannah River site. That's a large area, but it's not the largest DOE complex. We're actually the fourth largest in all of the complexes across the United States. When this land was chosen, it was chosen for several different reasons. Number one, we needed a large water source. That would be the Savannah River, our westernmost border. We needed that water for cooling water for our 5 reactors and also for our heavy water plant. Another reason the area was chosen, at the time it was out of the range of Russian bombers. This was the beginning of the Cold War. Savannah River site had to be built very quickly once it was announced where it was going to be. In an unprecedented construction project, likening it to the building of the Panama Canal and one of the largest and safest construction projects ever in the United States. We built the 5 reactors, 2 large production separation facilities, and all the other support facilities on our 310 square miles in just 5 years. Our first reactor actually went operable in less than 3 years. A few other reasons this area was chosen, it was mostly farmland. It fared very well for us for a quick construction. Also had a mild climate, which meant we could work year round. And also we had an extremely supportive community, and we still do. The height of our personnel here would have been back in the early 90s of about 26,000 people. And today we have, from all the contractors on site, about 11,500 or so people. Savannah River Nuclear Solutions is the managing and operating contractor here at Savannah River site for the Department of Energy. Some of our other contractors include Savannah River Remediation, which is our liquid waste contractor, Centerra, which is our paramilitary protective force here at the site, and Parsons, who built and will perform initial operations at the salt waste processing facility that we'll visit in just a little while. So let's talk a little bit more about Centerra. They are a private paramilitary protective force, and they are one of the largest in the world. Centerra is very good at protecting our assets here at Savannah River site. They actually have several boats that they go up and down the Savannah River, again, that being our westernmost border for the site, and also 2 helicopters that they can patrol our border from the air and any other areas that need to be taken care of. They have approximately 665 employees here at SRS. They guard different areas here. We have a perimeter barricade that we have personnel at. We have 10 barricades that come onto our site, and they're there 24/7 with those barricades, making sure people come on and off site safely with their badges. The Canine Protective Force, also run by Centerra, is very vital to us here. We check a lot of vehicles coming onto site and at different areas going into material access areas, limited areas, etc. We have canine units located there. These dogs are trained to detect anything gunpowder related or bomb making materials, and also to detect any kind of drugs or paraphernalia associated with drugs. Okay, so traveling along now, we're going from B area over to F area. So what do these letters mean? They really don't mean anything to the outside public. It's kind of a holdover from the Cold War era when secrecy was very vital to us out here. Our areas are spaced out strategically for a reason. Again, the secrecy of what that particular area did. Also, if you didn't need to know what went on in that area, you didn't know. There's a reason behind why our site is so big. For the operations that went on here for many years, we had to keep a barrier between us and the public. If we were to have any kind of a leak, chemical, radiological, we would be able to track that from our Atmospheric Technology Center located at Savannah River National Laboratory and let the public know what's coming. We can track wind direction, we can track the speed of the plume, etc., if we would have such a thing as that happen. So the large area to our left is what we call E area or echo area, but we call it the burial ground here at Savannah Riverside. For about 22 years, this served as our solid waste burial facility for low-level radioactive products such as shoe covers, clothing, tools, and some equipment that may not have been able to be decontaminated. We stopped using that in the early 1970s, and we stopped disposing of material here in that manner. What we did then was we took large concrete cask and we put that material inside. We covered that with a large concrete cover, and then we covered it with earth until we could figure out a better way to dispose of this transuranic waste, as we call it, a little bit higher level waste. So in the late 2000s, we started taking these concrete vaults and removing the material from it, reclassifying this material, and then we were able to ship it to the waste isolation pilot plant out in Carlsbad, New Mexico for permanent disposal. To date, we've sent about 30,000 55-gallon drums of contaminated material out of the state of South Carolina to be permanently disposed of. Now you can also see out the left side of the bus here that we have a lot of groundwater monitoring wells around E area, but not just around E area. We have about 3,000 of these wells throughout the site. But here in E area, they're very important to us because several years ago we determined that there was a groundwater plume underneath this burial ground that had tritiated water in it. Now this was where rainwater had seeped through our burial ground and contaminated the groundwater underneath. We came up with a great idea to use a process known as phytoremediation. That's where we take this groundwater, we then irrigate about 60 acres of pine trees. Our pine trees here at Savannah Riverside love water, so the more we irrigate these areas, the faster these trees grow. The water's taken up into the pine trees with the tritium in it. Since tritium has a very short half-life, the natural recurrence of this tritium would be to turn back into hydrogen itself, which would naturally go back into the atmosphere. So through the process of phytoremediation, we're getting rid of this tritiated water and we're feeding our pine trees at the same time. So we're at one of our main crossroads right now. We're just about in the center of the site geographically. So this is where most of our processing took place over the many, many years. Again, this is the furthest from the public domain here. So again, the safety factor that we want to emphasize here. Safety and security are our two biggest missions here at Savannah Riverside, other than what we do as a normal occupation on a daily basis. Okay, coming into H area now, or hotel area, several operations go on here. H Canyon is the largest shielded radiochemical separations facility operating still in the United States, and it's been doing so for a better part of 65 years. Now, while its mission is very different than when we first started here on site, it still does a valuable service for the United States. Over in L area, which is another one of our repurposed reactor areas, we have a storage basin of high enriched uranium fuel rods. These rods are brought over via rail to H Canyon. They're brought in through a series of airlocks, and this process is controlled by cranes from that point. What they do with this high enriched uranium is they separate it out. We take the waste product, we put it in H tank farm along with the other materials that we had from our Cold War legacy. And then the good material is actually shipped out to a fuel manufacturer where it's then converted into commercial fuel and used in a commercial reactor. And since we've been doing this process, we have converted about 310 metric tons of highly enriched uranium into commercial nuclear fuel. That's a win-win. We're getting rid of proliferable material and also turning it into something useful, such as electricity. The Savannah River Tritium Enterprise, also located here in H area, is a very important process for not just us here, but the nation and the world as well. The National Nuclear Security Administration manages the Savannah River Tritium Enterprise, but it's run by and operated by Savannah River Nuclear Solutions. This is the main reason that the site was built, actually. When we determined that the Russians had the ability to manufacture and detonate a nuclear warhead, that really put us into gear because they had that capability a lot sooner than we thought they would. We had the technology for the atomic bomb, as we proved in the World War II, but now we had the technology to also manufacture a hydrogen bomb, 100 times greater than the regular atomic weapon. Tritium is an isotope of hydrogen and a key component of nuclear weapons. The radioactive decay of tritium is about 5.5% a year, or a half-life of about 12 years. Existing warheads are sent back to the Tritium Enterprise and recycled, extracted, and purified before being sent out to our warfighters. Tritium radioactively decays to a product known as helium-3, which is a very valuable commodity. It's used by the Office of Science and neutron detection equipment that is being installed all over the world to protect our nation and its allies from terrorism by the Department of Homeland Security. So let's switch gears now and talk about our environmental management that we do here at Savannah Riverside. This is one of our main objectives now and very important missions that we're conducting here. The leftover waste from our Cold War processing for many years has been stored in 51 tanks at our F tank farm and H tank farm in those respective areas. Since 1997, 8 of those tanks have been successfully emptied, cleaned, and closed, filled with grout, never to be reused again. In fact, SRS accomplished the first high-level radioactive waste tank closure in the nation, where a specialized grout is placed into an empty tank for permanent closure. So the process is all managed by Savannah River Remediation, that is the liquid waste contractor here at Savannah River site now. There's 2 different commodities basically inside of these tanks. One of them is called salt waste, and that's the majority of the waste that's in the tank. It has some higher level waste in it, but it goes through a process that was previously known as the actinide removal process and the modular caustic side solvent extraction units that we had located over in H area. Now, that was a project that was a 3-year project, but it was so successful that it ran for 11 years and we actually processed some of that salt waste, helping us to empty those 8 tanks that we've already closed. They processed about 1 million gallons a year of salt waste. Well, salt waste processing facility is going to up our game tremendously in helping our tanks to get closed much sooner, reducing the threat to our environment. We'll now be able to process about 9 million gallons of this salt waste a year, emptying our tanks much sooner than we expected. The other product that we have in the tank is called sludge waste. It makes up a very small portion of what's in the tank, but it has the highest amount of curies or radioactivity in it. And we have to mix it with several different things, mostly water, to get it to where it would flow through the pipes going over to our next facility that we're about to visit in S area. This is known as the Defense Waste Processing Facility. So as we turn into S area here, you'll notice out the left side of the bus, the sign, but also behind it is a large metal canister. This canister is about 10 feet tall, 2 feet in diameter, and about 3/8 of an inch thick stainless steel. Now these canisters are what holds this process material that comes from the Defense Waste Processing Facility. So this sludge waste that comes into the Defense Waste Processing Facility is sent through several processes. It's then mixed in with a product known as borosilicate glass, and together this mixture is heated up to 2100 degrees Fahrenheit in our 65-ton steel and ceramic melter. These 10-foot tall canisters weigh about 5,000 pounds when filled, and they're filled with the liquid waste mixed with the borosilicate glass. It takes about a day and a half to fill one of those canisters. So after the canister is filled, it's set off to the side and it cools down, and then it's blasted with a silicate mixture that decontaminates the outside of the canister. The canister is then transported in our one-of-a-kind transport vehicle over to one of our glass waste storage buildings here in this area. Now this is temporary storage for us here at Savannah Riverside. Once a permanent federal repository is established, this material will then be moved to that for permanent storage. Just across the street from this area is Zulu area, where the saltstone material is stored. Now this is where the material is sent over from salt waste processing facility. It's mixed with concrete and slag and basically turned into a hard concrete product and stored in large tanks. In the past, we've used 3 and 5 million gallon tanks to store the salt stone here for permanent disposal at Savannah Riverside, since it is a low-level radioactive waste. But now with salt waste processing facility coming online, we're going to be processing a lot more. A couple of years ago, we started building what we call the mega tanks. We're going to build 7 of these 32 million gallon salt stone disposal units in total, and they will hold the rest of the salt waste that we'll process at SWPF. So from Z area, we have a pretty good little ride over to C area. This is one of our old reactors that we had in operation. Again, none of our reactors are operating here at Savannah Riverside. P reactor and R reactor have been permanently closed. They've been filled with grout and all the entrances have been shut. We don't have to do any more monitoring of these facilities, and they're basically large blocks of concrete sitting out in the middle of nowhere. This process was approved by the Environmental Protection Agency and also by South Carolina Department of Health and Environmental Control. Out of our other 3 reactors, we've actually repurposed 2. Because of its robust construction, security infrastructure, and rigorous seismic and structural upgrades, K area was chosen by DOE in early 2000 to serve as their premier plutonium storage facility. But an additional mission is changing K area. Downblend or dilute and dispose involves blending plutonium oxide that results in a mixture that is more secure and not usable for weapons that can be safely disposed of at the Waste Isolation Pilot Plant in New Mexico. This also helps get nuclear materials out of the state of South Carolina. Now over in L area, we repurposed it to hold spent nuclear fuel. These are aluminum rods that have been irradiated. We have a 3.4 million gallon water pool over there that is used mainly for shielding. It's not because the rods are thermally hot. This is the material that basically we're repurposing through our H Canyon processing. So as we come into our largest biomass facility here at Savannah Riverside, you can see the steam lines of the steam that it produces for us. This steam is used for heating of buildings and also for processes that go on inside some of those buildings. Our largest biomass facility is run by Amoresco, and it receives about 50 semi-truckloads of wood chips on a daily basis. We're very proud of the fact that this facility is the largest biomass cogeneration facility of its type in operation in the federal sector. This plant produces 100% of the steam that we use here on site, and also about 28% of the electricity that we use. It's carbon neutral, and the trees that the biomass comes from is a renewable resource, and we have an abundance of it here in the Southeast.
We are lovers, we are fighters, flying higher and we never give. We are lovers, we are fighters, flying higher and we never give. Writing our own story, yeah, 'cause we're legends. Writing our own story, yeah, 'cause we're legends. A fire burning in our bones. A fire burning in our bones. And nothing can put out the glow.
Wow, what a great tour. Thanks for riding along with us today. You know, we love giving these tours here at Savannah Riverside, especially to our public. Our rich 70-year history means a lot to us here, and we love showing it off. If you want some more information, you can go to www.srs.gov and visit us on social media as well. Thanks everybody again for riding along with us.